everybody. We are going to do 9B now, and we're going to talk about linear modeling. I wrote on the board that it's constant absolute change. So you remember probably in 9A we talked about, okay, well, what if the price of gas increases 10 cents every week? Okay, or 4 cents every week, whatever the example was. We just keep adding 4 cents over and over for however many weeks we're talking about. So that's a constant absolute change, and that works in linear modeling. However, and this is more to come in the next section, it's different than exponential modeling. Remember, exponential modeling or exponential growth we talked a little bit about in 9A. That's a constant relative change or a percentage change. So make sure you really understand the difference between what linear modeling is or what linear modeling is or what linear growth is, and the same thing with exponential. We need to understand the difference between those two. We're going to do 3 total sections on kind of the differences between them and how to use both of them and when to use both of them. So it's going to be a huge part of your final test. So just make sure you understand those differences. And as always, if you have any questions, you know where to find me. Via email, you have my email address. You can text, call, any of that as well. How are you guys doing? Hopefully well. We are starting to kind of wind up the whole semester. We're going to do 9B and 9C from chapter 9, and then we're going to do either 1 or 2 sections in chapter 10. And like I told you before, your final exam will be due on Friday, May 8th, and I'm probably going to give you until midnight for that one. So it's going to be in my math lab, just as always. It'll be timed, but you have to take it by that date, and there are absolutely no extensions. So once you see it in there, I would finish up the homework, make sure you have plenty of time, but after that I cannot give you any more time. So make sure it is completed by the time it's due. Super important because grades are due, so we're actually not allowed to give you any more time. Okay, so let's talk about linear modeling a little bit. Hopefully you guys are all doing well. We have about, well, depending on when you're watching this video, we have somewhere between 1 to 2 weeks left of classes, and then we'll be on to summer, teaching one summer class. I'm teaching this class again in the summer. So hey, if you're not successful, come join me. I'll be there in the summer. And tell your friends, come take my class in the summer. We're gonna have fun, you know, ish. We actually will be online again all summer too, it looks like. So, all right, let's look at the first example in the worksheet for 9B. So I'm going to show you a couple different ways to do it. You might have one way right in your head. It works for you every time. Fine. Great. In my math lab, they're going to ask you to write out equations or functions. So I'm going to show you how to do that as well. And it becomes more and more useful as you do more and more of this stuff. And I still use some of these things in real life. So I'll show you what I mean. Let's look at number 1. The water depth in a lake decreases at a rate of 2 inches per day because of evaporation. Okay. How much does the water depth change in 8 days? Well, if it's decreasing 2 inches per day for 8 days, you can probably do that math pretty quickly. It decreases 16 inches, right? So 8 days, 2 inches per day. Okay, it's going to decrease 16 inches. You probably did that one in your head. What about the next one? In 15 days. Yeah, 2 inches, it's 30 inches, right? You're just multiplying 15 times 2. So we can write this as an equation. We can say that the change of water in the lake is equal to negative 2 inches per day. Right, and they literally tell you that in the first sentence. The water depth in a lake decreases or changes at a rate of 2 inches per day, right? It decreases, so that tells me it's negative per day. Okay, it changes negative 2 inches for every day. So if I told you 40 days, right, you'd be doing it exactly like you did here. You'd plug it in, you'd say negative 80 inches. This is actually a kind of like a proper way to write an equation. I know it might seem even more complicated than what you need. In my math lab, they're going to ask you to do this, and then they're going to actually have you graph some of these. So they're trying to show you kind of how all this comes together. So depending on what the question asks you in my math lab, you may need to kind of write it out that way, or you may not. and that's fine. If you have any questions about why this kind of works this way, just let me know. What about number 2? Read through number 2. Okay, the gas station owner finds that for every penny increase in the price of gas, she sells 80 fewer gallons. Okay, so her prices go up, but the amount of gas she sells goes down. Well, that makes sense. We call these either opposite or inverse functions. As one goes up, the other one goes down. How much more or less gas will she sell if she raises the price 8 cents per gallon? So if the price goes up 8 cents, how much more or less will she sell? Well, she sells 80 fewer gallons for every cent it goes up. So if it goes up 8 cents, I'm going to multiply that times negative 80, right? And I'll get negative 640 gallons, right? Negative 80 because it'll decrease. The price will decrease. The amount of gallons will decrease as the price goes up. Well, okay, but what about if she decreases the price by 6 cents? Well, this is decreasing the price by 6 cents. That would almost be like writing negative 6 cents times negative 80 would equal what? Positive 480, right? She would sell 480 more gallons. Good. All right. What about number 3? Read through number 3. According to one formula, your maximum heart rate in beats per minute is 220 minus your age in years. Okay. How much does your maximum heart rate change from age 25 to age 40? And what is your maximum heart rate at age 70? Okay, well, if it's just 220 minus your age, and your age changes 15 years, then your maximum heart rate must change what? 15 years also. Okay. And what is your maximum heart rate at age 70? Well, again, remember the formula that they give us is 220 minus your age. If your age is 70, your max heart rate must be 150 beats per minute. Good. All right, what about number 4? Again, reach out to me if you have questions on these. In 2012, Dana Vollmer set the women's world record in the 100-meter butterfly, which is swimming, with a time of 55.98 seconds. Feel like we're going to need to use that number, so I'll write it down. Assume that the world record falls at a constant rate of 0.05 seconds per year. What does the model predict for the record in 2020? Okay, a few different ways to do this one. This is where it started, right? But it's going to fall, so it's going to be negative at 500th of a second per year. For every year, we're going to lose time, right? You want to lose time because you want to be faster at swimming. So how many years are we talking about in this one? 8 years, right? Because it's from 2012 to 2020. We're not going to get to see this one, right? If it's a world record, I don't know. Is that Olympics? Yeah, world record. So we won't get to know for 2020, but we'll know for 2021. So this is a difference of negative 0.40 seconds. So then what's the record predicted for 2020? This minus this, right? Will give you 55.58 seconds. Be interesting to see if we're close to that now. Great. Those are the first 4. Let's go to the next page. Talk about leasing a car. So it tells you the cost of leasing a car is $1,000 for the down payment and processing fee. Okay, that's one fee, one-time payment of $1,000, plus $360 per month. For how many months can you lease a car with $3,680? 55 different ways to do this one. I'm going to do it one way, and I bet your way is almost exactly the same as mine, even though you might not kind of write out the first step. So if I have $3,680, right, I know that's how much money I can spend. I know I have to pay a $1,000 down payment up front. Plus I know for every month I'm gonna have to pay an additional $360 for every month I own the car. Sorry, that's really messy. Let me just write it neater. $360 for every month I owe the car. Right, if my math lab's asking you for an equation, this is what they're talking about. Okay, they're saying, all right, the cost of leasing the car is equal to the down payment plus the monthly payment times the number of months you own the car. So we're multiplying these two. Sorry, I just need a bigger board as usual. So the cost, the total cost, is equal to the down payment, right? You have to pay that whether you lease the car for 1 month or whether you lease the car for 50 months. It doesn't matter. You just pay this one-time fee. Then you're adding to that how much you have to pay per month times the number of months you own the car or you could own the car. Okay, so to figure it out, I kind of start with this, okay, all the information I know, and then I work backwards. I'm going to erase this line, so make sure you write it down. You can always pause the video and go back. Okay, I'm trying to figure out, well, how many months can I lease this car for? So I'm just going to do my algebra. Remember, subtract it from both sides. So I have 2,680. Okay, because I subtracted the fee right off the bat, right? Which is probably what you did as well, even if you didn't necessarily write out that first step. You probably said, well, I know I have to pay the 1,000 no matter what. Now you're just going to take this, right, and divide it by 360. Because you know if you say, well, I have this much cash left over, if I divide it by $360, I'll be able to figure out how many months I have. And again, you may not have needed to write it all out. I'm just showing you a quick way to know how to solve it if you're not exactly sure how to start. What'd you get? Like 7.14 months. So really she can lease the car for 7 full months and then another little bit. Good. On to number 6. In 2000, the population of a town began increasing at a rate of 300 people per year, okay? The 2000 population was 1,500. So this is in the year 2000. I'm going to label so I don't mess myself up. The population was 1,500 people. Okay, what is your projection for the population in the year 2020? Well, if it increased by 300 people a year, well, how many years went by? 20 years, right? From 2000 to 2020. We can say, well, for 20 years, we increased by 300 people. Hey, that's 60,000 people. I had to think about that for a second. Wait, 6,000 or 60,000? No, 3 zeros. Bad teacher. 1, 2, 3. 1, 2, 3. There we go. 6,000 people. Okay, and then just add the 1,500 to it. So the population in 2020 would be 7,500. Whoa, almost fell over there. Good. Spoiler alert, this is not how it works. Population is definitely one that you talk about exponential growth with. This is a pretty bad example. But they're showing you what's the difference, right? If a town started at 1,500 and then 20 years later went all the way up to 7,500, that's pretty huge growth. I mean, that is 20% the first year. That's a huge population growth. But you know what? It could happen. Maybe it happened. Number 7 is just like number 5. Same exact example. If you want to do it and send it to me, I'm happy to look at it for you. It's just the exact same example as number 5, so I'm going to skip it. I suggest you do it though, because there may be a question like number 5 or number 7 on the test. It could happen. Do I give hints well from home, or what do you think? I haven't made the test yet, so I don't know, but you'll see one like it in my math lab, that's for sure. All right, on to number 8. Let's talk about just plain old boring regular equations. Y equals mx plus b. Remember this one? I said to my other classes before, if I ever got like a math tattoo, this might be what I get. I know. The M is the slope, and the B, or the plus or minus B, is what we call the y-intercept. Okay, the slope is exactly what it sounds like. A slope of something, right? Like a slope on a mountain is how steep it is. The slope of a line could be like this. This would be a positive slope because if you go from left to right, you're going uphill. This would be a positive slope. This would be a negative slope because you're going downhill if you go from left to right. This line would be very steep. This line would be very steep. The slope would be greater than 1. This line would be very, here, let me do one over here. This line would be very shallow. The slope would be less than 1. Okay. This line would also be very steep. It's almost a slope that's undefined. This would be a very steep negative. It would be less than -1, and this line would be more gradual, but it's all negative, right? You're going downhill. Okay, that's a little bit about slope. The slope tells us, how does this line tilt? We know it's a straight line if we're talking about a linear equation. It's right in the word linear line. So the slope tells us all about how does the line tilt? Does it go uphill or downhill? Is it steep or is it more gradual? The plus B is the y-intercept. That tells us if we have a little graph, and this is our x-axis and this is our y-axis, where does the line hit on the y-axis? So with just those two pieces of information, we can graph an entire line. That's all we need. So let's look at that in terms of the equations that they gave us here. They gave us one that says y is equal to -2x, and the x and the y always stay put, plus 5. So in the number 8, they say find the slope in the y-intercept first. So let's do that. What is the slope of this line? It's -2. Good. It's everything that comes after the equal sign and before the x, and that includes the sign. So it's -2. We can also write the slope in the form of rise over run, and that'll help us when we graph it. So you can always take any number and put it over 1. So a slope of -2 also means a slope of -2 over 1. And I'll show you why we need this when we graph this line. All right, what's the y-intercept here? Y-intercept. It's +5, right? All right, so write those two things down. Make sure you have the slope written down and the y-intercept written down. Now I'm going to erase this board and I'm going to sketch a graph for some of the values. I'm not going to do all 20 of these values, but so we said the slope was what? -2, and the y-intercept was 5. The slope is -2, and the y-intercept is +5. Is that what I said? +5. That's what I meant. So the first thing I have to do when I'm graphing a line with these two pieces of information, my first step is to plot the y-intercept. So on my beautiful graph here, I'm going to go 1, 2, 3, 4, 5, and I'm going to make a point. That is my first point. So I know I only need 2 points to connect the dots and form a straight line, right? If you're graphing something that looks more like this, or looks like this, or something crazy like that, you definitely need more than 2 points. But anytime you're graphing a linear equation that's a straight line, you only need 2 points. So we already did half of it. The second step with this is from the y-intercept, use your slope as rise over run to plot a second point. Okay, what does that mean? So from here, I'm going to start with my pen here, and I'm going to use the slope in the form rise over run. Okay, rise. A balloon rises. It can only go up or down in theory. run. When you run side to side. Okay, so when I'm talking about the rise, which is going to be my -2, right in here. That means from this point, I need to rise -2. Well, if you're rising negative, you're going down. Okay, so I'm going to let my marker hover here. Now I have to run +1. That means from here, I'm going to go to the right one. There's my second point. Now I have enough information and I can just, that was bad connecting the dots, but in theory, right, just go right through the dots and there's your line. Done. That's it. Okay. So first, plot your y-intercept. That's 1 point. The second step is the long point. So you start here. You use your slope as rise over run. So you go down 2, and then it's a +1, so you go to the right 1. Put the dot, connect the dots, and you're done. A couple questions that I'm going to answer, even though we didn't necessarily ask them. Well, this is a -2 and this is a +1, but we all know that -2 over 1 sometimes looks like this, -2 over 1. Where does that negative sign go? Does it go up here? Does it go down here? Does it go both? There's only one wrong answer. This is okay, and this is okay. The only one that's incorrect is this. Oh. Why? Because a negative over a negative makes them positive, right? So this is the wrong thing to do. Well, okay, great, I got that, but this is me being you, right? Like talking to me. So what if you instead, for some reason, had your negative sign on the bottom? Wouldn't that be a different line? No, it wouldn't. And this is why. You were like, I already know. If you started here and you rose 2 and then you went negative, well, remember, this is my sketch. So if you rose 2 and you went -1, you would actually still fall in the exact same line. And remember, it's just a sketch. In my math lab, you can be much more precise, but I'm just sketching it for you on the board. The point is, as long as there's only one negative sign, it can go up top or down bottom. It just cannot be both. All right, number 9 is exactly the same as number 8. But again, if you want to do number 9 out, and you'll definitely see one like this, because I want to make sure you understand what the definition is and all that. If you want to do out number 9 and like text me a picture or whatever, or email me a picture, totally fine. I'm happy to look at it for you. In number 10, you're starting with the tree that already has a 4-inch diameter. And remember that it increases 0.2 each year. So when you start observing the tree, its diameter is already 4 inches. They want you to start at the 4 inches and count your way back. So feel free to email me about that one too. That's it. That's all I have for 9B. I hope you guys are doing well. And if you have any questions, please, please, please feel free to reach out. Hope to hear from you guys soon.